Okay, hi everyone, this is the Trig video tutorial for Trig Quadratics, which is SIG test problem number 41. So in this video, I'm going to go through a few of these problems and explain how to do them, and then at the end I'll show the answers. So here we go. Okay, so here's the first problem. We're going to do A. So in these problems, you want to start out, you either want to have sine or cosine, and you can see here we have cosine, we have sine squared. So we're going to need to change the sine squared to 1 minus cosine squared. So here we go. Okay, so now we want to distribute this 3. Okay, so now everything is distributed out, and we can combine the 3 and the 1 on this side, so it'd be 4 minus 3 cosine squared. Okay, so now we want to move everything to one side, and I personally think it's easier to move to make the cosine squared positive, so that's why we're going to move this to this side. So we add 3 cosine squared to this side, and you subtract 4 to move it over. Okay, so now we have 3 cosine squared plus 2 cosine minus 1. Now you just have to factor it like a regular quadratic. Instead of x's though, you have your cosines. So you have 3 cosine, cosine, and then you think, what could go in here that multiplies to -1 but adds to 2, and you could do +1, -1, just to double check. -1 times +1 is -1, and then you have 3 cosine minus cosine is 2 cosine. So there we go. And then you just set it equal to 0, and you get cosine equals -1 on this side, and cosine equals 1/3 on this side. Okay, so now we can go and draw our unit circle, and we can see that we can use the unit circle to find cosine of -1. So we go here, because this is where cosine equals -1, and we know that is pi on the unit circle. This is pi, and then we look up here and we see that we do have a domain, so we just leave it as pi. We don't write 2 pi n because that's only if you don't have a domain. And then we also have cosine of 1/3. So cosine of 1/3 is not in a special right triangle or a 30, 60, 90 right triangle. So we have to go on our calculator and we have to do the inverse of cosine 1/3 to figure it out. So we do, on this calculator, you do second cosine to do the inverse, 1 divided by 3, and you get 1.230959417, and we only want to go to 3 decimal places, so it's just going to be 1.231. But we also have to remember that cosine of 1/3 is in 2 spots because cosine is positive in 2 spots. So right here and right here. So 1.231 that we just found is the spot right here. But we need to find this spot. So we have to go back to our calculator and we do 2 pi minus what we just found. And we get 5.052222589, and still we only want to go to 3 decimal spots, so it will be 5.052. Okay, so in the end, our answers are going to be pi, 1.231, and 5.052. Okay, now we're on to the second problem. So first, we need to recognize that this is a rap song. So we need to get rid of that first. And so we remember our rap song is sine, cosine, cosine, sine, cosine, cosine, sine, sine. And this is cosine, so it would be the second part of the rap song we're going to use. So we write it out. And then we plug these in alternating. So we do theta, pi over 2, theta, pi over 2. Okay. And then cosine is the cosopposite, so it's going to be the opposite of what it is in here. So it's going to be, since it's negative or it's subtraction here, you're going to be adding them here. So then we go to our unit circle, and we see cosine of pi over 2 is 0, so this would be 0. And then sine of pi over 2 is 1, so it's just 1 times sine, so it's just sine. And then you need to either make everything sine or cosine, and so we can change this to sine, because then everything will be sine. So it will be 1 minus 2, 1 minus sine squared. Okay, and now you need to distribute the negative 2, so it would be 1 minus 2 plus 2 sine squared. And now you combine the 1 and the negative 2, so it would be negative 1 plus 2 sine squared. And then, since the sine squared is positive, I'd recommend moving the sine over and just leaving the sine squared here. So minus sine, and then we get 2 sine squared minus sine minus 1. Okay. Now we're just going to factor it. And then what goes here, that will multiply to negative 1, but add to negative 1 sine. And that would be, we could put negative 1 here and plus 1 here. And just to double check, positive 1 times negative 1 is negative 1. That's right. And then we have negative 2 sine plus sine, which would be negative sine. Okay, and then we set it equal to 0, and then you get sine equals positive 1, and then set this equal to 0, you get 2 sine plus 1 equals 0, and then you get sine equals negative 1 over 2, or negative 1/2. Okay, so then we go to our unit circle, and then we see where does sine equal 1, and we know that's up here, which is pi over 2. And then we look at the beginning of our problem, and we see there's no domain, right? No domain, just to remind yourself that this means that you have to write 2 pi n at the end of your answer. So you're going to have pi over 2 plus 2 pi n, and then we still need to find sine of negative 1/2. So this goes along with your 30, 60, 90 triangle. So you don't need your calculator, so you just go where sine is negative, which is in these two locations. And then, you know, when sine is 1/2, the angle across from it is 30 degrees. And when the angle is 30 degrees, you know the denominator is going to be 6. So it's going to be 7 pi over 6 and 11 pi over 6. And then you write your answers down here. Plus 2 pi n because there's no domain. Okay, then we're running out of room a little bit here, but here are the final answers. Pi over 2 plus 2 pi n, 7 pi over 6 plus 2 pi n, 11 pi over 6 plus 2 pi n. So by now I've gone through a few of these problems, and I hope this video has helped you understand trig quadratics better. And there's a few more example problems, so I've done them, and now I'm going to show you all the steps and the answers. So if you want to see them, you can pause the video to see how I did them and the answers for them. So here's the first one. then for problems like this, there can be multiple answers for the same location on the unit circle. So this problem shows both answers, and you can put either one, just whatever you prefer, but just so you know, there can be multiple answers for certain problems for one location.